Hi all. Today we are going to discuss construction, working principle, and way characteristics of diode. I think for the last lecture we have discussed about the construction. So in this session we are going to discuss about working principle and way characteristics of diode. Right. So I think we have to recall for the last session what are the information we are discussed under the construction of diode. First, we have to discuss. I think anyone can say yes. What is semiconductor? Type of semiconductor. Very good. And what is depletion region? Very good. How the depletion region is formed and what type of material we are. There are two type of material in the diode. Very good. P type and N type. And how can we made a P type and N type material? Yes, of course, there are two type of material semiconductor is available, only intrinsic and extrinsic. This intrinsic means number of electrons and holes are equal, and it's also called as a pure semiconductor. Very good. Extrinsic means we have to add an impurity, maybe trivalent or pentavalent. So based on this, we are increasing the number of holes or number of electrons. So based on the number of electrons, if is increasing, adding with the impurity, as it is called as the N type. Very good. And if you are adding impurity, it increases the holes, that it can as a P type material. Very good. So today we are going to see construction. Already we are discussed. So working of PN diode. So working of PN diode means for the last lecture we have discussed there are depletion regions are formed when we are connecting P-type material and N-type material. So if you are broken the barrier potential or barrier, that is depletion region only, the electron flow from P to N-type and current flow from N to P. So we have to connect the uh, bias through bias for the P-type material and the N-type material. So we know that bias means we are applying the external voltage to the uh, diode, but we can say it is the bias. So external source means we can say it is the battery. So to show see the diagram, the P-type material is connected to the N and N is connected to the P. That we call it as the reverse bias. So diode can be work in two biasing. One is forward bias and another one is a reverse bias. So if we are connecting P to P, N to N, that we call it as the forward bias. Here the P material, P-type material is connected to the N and the N-type material is connected to the P. So it is in the reverse bias. If you are increasing the voltage reverse bias, what will happen? That is the P to P, N to N, the depletion region may be wider. So if you are wider, then if you are applying more voltage based on the, if you are selecting the silicon, the barrier potential more than 0.7 volt only, it can start to conduct. And for the germanium 0.3, we can apply the external bias voltage more than the 3 only, the barrier potential will be broken and the electron flow from P to N or N to P based on the biasing. So here we are applying the more than 0.7 voltage only, the depletion region will be broken and the electron flow from P to N, the current flow will be takes place. And this is called as the reverse bias. And for the forward bias, see the diagram P to P and N to N, we can say it is the forward bias. So if you are applying the voltage, it is also the same. If you are applying a voltage through the battery and P to P, N to N means the depletion region may be not wider like reverse bias. So if you are applying more than 0.7 voltage, it can be works and start conducting the current. If you are increasing the voltage, current will be increasing. And for example, if you are applying 2 volt, according to that the current will be increased, and 3 volt according to that the current will be increased in the forward bias. It will not happen in the reverse bias because the wider depletion regions are available. If you are applying more than the voltage, the minority carrier of flow, that is the minimum amount of current only flow in the reverse bias. But it is that's why we can call it as the reverse bias. The diode will not conduct, and the in forward bias the diode will be conduct. So there are two working modes are available in PN junction diode. One is the forward biasing condition and another one is the reverse biasing condition. So all of you keep in mind, in reverse bias there is a wider depletion region only. It will not conduct the reverse bias. And forward bias, there is a more than, based on the material, if you are applying more than 0.7 or 0.3, the depletion region will be breakdown and the current flow will be start from P to N or N to P, right? So based on this we can say that diode, PN junction diode works only in forward bias. So see you in the next class. That is, we can say discuss VI characteristics in the next section. Thank you all.